Hello and welcome back. I'm glad you found your way here again tonight. There's nothing you need to do right now except settle in and let your body grow heavy against the bed. Let your breathing slow. Let your thoughts loosen their grip on the day, the way a hand slowly opens. Tonight, we're finally drifting all the way out, past the clouds, past the edge of the sky, into the quiet, endless dark where the stars live. Some of what you hear tonight may surprise you. Some of it may simply settle over you like starlight, familiar and strange all at once. If any of this helps you unwind, consider subscribing to Drowsy with Facts, so you can drift off with us again soon. For now, let's begin. Space itself is completely silent. Out there, there's no air to carry sound the way it travels here on Earth. So even something as violent as a star collapsing happens in absolute, total silence. No matter how dramatic it might look, the sun is almost impossible to picture the true size of. More than 1 million Earths could fit inside it. And if you shrank the sun down to the size of a basketball, Earth would be smaller than a grain of sand resting beside it. Sunlight takes about 8 minutes to travel the 93 million miles between the sun and Earth, which means the warmth on your skin on a bright afternoon actually left the sun's surface 8 minutes before it ever reached you. Saturn is so light for its size, made almost entirely of gas, that if you could find an ocean large enough to hold it, the planet would actually float rather than sink. A single day on Venus is stranger than anywhere else in the solar system. The planet spins so slowly that one full rotation takes longer than one full trip around the sun, meaning a year passes there faster than a single day does. There are more stars scattered across the universe than there are grains of sand on every beach on Earth combined, a number so large it becomes almost impossible to properly hold in mind. When certain massive stars collapse, the matter packs together so tightly that a single teaspoon of the results would weigh about as much as a mountain here on Earth. On Jupiter, a storm larger than the entire planet Earth has been raging continuously for at least 300 years, swirling and churning in the same general region of its atmosphere the whole time. Space is closer than most people realize. If you could drive straight upward in a car at ordinary highway speed, you'd cross into space in about an hour, a surprisingly short trip compared to how far away it feels. When astronauts walked on the moon, they left footprints in dust that will likely remain undisturbed for 1 million years, since there's no wind on the moon to slowly erase them the way it would here on Earth. Some stars visible in the night sky have already died, and their light is simply still finishing its long journey to your eyes, arriving years or even centuries after the star itself stopped existing. Our galaxy, the Milky Way, is so vast that light itself, the fastest thing in the universe, takes about 100,000 years to cross from one edge to the other. Mars is home to the largest volcano in the solar system, standing nearly 3 times taller than Mount Everest, rising up out of the thin red Martian atmosphere in complete stillness. In the vacuum of space, water would boil and freeze at nearly the same time, since the extremely low pressure out there doesn't allow it to stay liquid the way it comfortably does here on Earth. Every planet in our solar system carries the name of an ancient god, except for one. Earth is the only planet whose name doesn't reach back to old mythology at all. Neptune moves so slowly around the sun that a single year there lasts about 165 Earth years. and it still hasn't completed even one full orbit since it was first discovered. The largest known star in the universe is so enormous that if it were placed where our sun currently sits, its outer edge would swallow the entire orbit of Jupiter. Even the emptiest stretches of space aren't perfectly empty. A few stray atoms still drift through even the most desolate regions, spread thin and quiet across the dark. Saturn's rings are made mostly of ice, with individual pieces ranging from specks as small as dust to chunks as large as houses, all orbiting together in the same wide, glittering band. The International Space Station moves so quickly around the Earth that astronauts aboard it see a sunrise roughly every 90 minutes, far more often than anyone experiences on the ground. Black holes don't pull things in like some kind of vacuum cleaner. Instead, space itself bends and curves around them, and anything nearby simply follows that curve. The observable universe stretches about 93 billion light years across, and even that staggering distance is likely only a small portion of everything that actually exists. Every second, the sun converts roughly 4 million tons of its own mass directly into light, a quiet, continuous transformation that has been happening for billions of years already. The moon is slowly drifting away from Earth, moving about 1.5 inches farther every single year, so gradually that it will be many millions of years before it makes any noticeable difference at all. A full year on Mercury lasts just 88 Earth days, the shortest of any planet in the solar system, circling the sun far more quickly than anything farther out. Galaxies can collide with one another without a single star actually touching, since the space between individual stars, even within a galaxy, is simply too vast for direct collisions to happen. Uranus rotates almost entirely on its side, likely knocked over long ago by something massive colliding with it early in the solar system's history. Light from the very edge of the observable universe has been traveling toward us for over 13 billion years, meaning it began its journey not long after the universe itself first came into being. A spoonful of a certain kind of collapsed, burnt-out star would weigh about as much as an elephant. A strange and almost impossible density to properly picture. Space carries a faint scent, according to astronauts, one they describe as something like seared steak or hot metal, a smell that sometimes lingers on equipment after a spacewalk. Some comets take so long to complete a single orbit around the sun that they won't return again for tens of thousands of years, quietly looping through the outer solar system, far longer than any human lifetime. A single bolt of lightning on Jupiter can be up to 1,000 times more powerful than one here on Earth, flickering silently through clouds far thicker than our own. The sun accounts for more than 99% of all the mass in our entire solar system, with every planet, moon, and asteroid combined making up only a tiny fraction of the rest. If you somehow fell into a black hole, time would appear to anyone watching from outside to slow down more and more the closer you got, eventually seeming to stop entirely from their point of view. Space telescopes allow us to see galaxies not just far away, but far back in time as well, since the light reaching us left those galaxies billions of years before it ever arrived. Some planets discovered orbiting distant stars circle two suns at once, and standing on such a world would mean watching two shadows cast at the same time. The largest cosmic structure ever identified is a vast wall of galaxies stretching more than 10 billion light years across, so enormous it barely fits any reasonable comparison at all. Astronauts can grow slightly taller during long stays in space, as the lack of gravity allows their spines to stretch out gently, without the usual weight compressing them. There are frozen lakes of liquid methane on one of Saturn's moons, one of the only places besides Earth where a stable liquid has been found resting openly on a surface. It would take a modern jet plane more than 800,000 years to reach the nearest star beyond our own sun, a distance that remains almost incomprehensibly vast, even at considerable speed. The universe isn't simply expanding. It's expanding faster and faster with every passing year, a discovery that genuinely surprised the scientists who first confirmed it. On Venus, thick clouds made of sulfuric acid drift endlessly above a scorched, pressurized surface, making it one of the most hostile planets in the entire solar system. The dark side of the moon isn't actually dark in the way the name suggests. It simply faces away from Earth, and it still receives its own fair share of sunlight throughout the month. A year on Pluto lasts about 248 Earth years, so slow and distant that it still hasn't completed a single orbit since its discovery in the 20th century. If our sun were shrunk down to the size of a single grain of sand, the next nearest star would still be over 4 miles away at that same tiny scale. Rogue planets drift alone through space with no star to orbit at all, wandering endlessly through the dark without the warmth or light any ordinary planet would normally have. Saturn's largest moon has rivers, lakes, and rainfall, but made entirely of liquid methane instead of water, an alien echo of Earth's own water cycle, playing out in a much colder world. Light from the Andromeda Galaxy, the nearest large galaxy to our own, left its source long before humans had learned to build cities, only now finally arriving at your eyes. Most of the universe by sheer volume is simply empty space, with galaxies and stars scattered thinly across a darkness that vastly outweighs everything within it. Somewhere out there, starlight still arriving tonight left its source before the pyramids were ever built. A quiet, patient messenger crossing an almost unimaginable distance. The faint leftover glow from the universe's very beginning can still be detected today, scattered evenly in every direction you could possibly look. Even now, new stars are quietly being born inside vast, cold clouds of dust and gas, a slow process unfolding constantly somewhere across the galaxy. Some galaxies drift entirely alone, with no close neighbors for millions of light years in any direction, isolated in a way that's difficult to imagine. The night sky you see is really a layered window into the past, with starlight of many different ages all arriving at your eyes at exactly the same moment. Space has no true up or down. There's only whatever direction you happen to be facing at the time, with no fixed reference point to orient yourself by. Everything you're made of, every atom in your body, was once forged in the heart of a star, scattered outward long before the Earth itself ever existed. Even black holes, given enough time, eventually fade and grow quiet, though the timescales involved stretch so far beyond anything comparable to a human life. The stars visible above you tonight are largely the same ones that lit the sky 10,000 years ago, their positions shifting only very slowly across such an enormous stretch of time. The Milky Way is on a slow collision course with our nearest large galactic neighbor, though the eventual merge won't happen for billions of years yet. Saturn could, in theory, produce a strange whistling hum if its natural radio emissions were sped up into a range audible to human ears, an eerie signal picked up by passing instruments. Jupiter's moons include one with more active volcanoes than anywhere else in the solar system, constantly resurfacing itself with fresh volcanic material. The largest known planet outside our solar system is so big that it challenges the usual boundary scientists use to distinguish a planet from a small, failed star. Certain nebulae, vast clouds of gas and dust scattered through the galaxy, glow in colors and shapes striking enough that many have earned their own descriptive nicknames from the astronomers who study them. A single day on Earth is slowly getting longer over enormous stretches of time as the moon's gravity gradually slows our planet's rotation by the tiniest possible fraction each year. The largest moons in our solar system are, in some cases, actually bigger than the planet Mercury, blurring the usual tidy distinction between a moon and a small planet. Certain exoplanets discovered by astronomers orbit so close to their star that a single year there lasts only a matter of hours rather than anything resembling an Earth year. Deep space probes launched decades ago continue drifting outward even now, carrying golden records and messages intended for whoever, if anyone, might one day encounter them. The coldest known natural place in the universe isn't found on any planet at all, but rather within a vast expanding cloud of gas drifting through interstellar space. Jupiter's magnetic field is so powerful that it stretches far beyond the planet itself, forming one of the largest structures in the entire solar system. Invisible, but genuinely enormous. Certain stars pulse and dim in remarkably regular, predictable patterns, allowing astronomers to use them as reliable cosmic distance markers across the galaxy. Space debris orbiting Earth, remnants of old satellites and mission hardware, is carefully tracked, since even a small fragment moving at orbital speed carries enough energy to seriously damage a spacecraft. The largest known asteroid in our solar system is so massive that it's also classified as a dwarf planet, occupying an unusual middle ground between the two categories. Certain moons in our solar system are believed to hide entire liquid oceans beneath their icy surfaces, kept warm not by sunlight, but by the gravitational flexing of their much larger host planet. The gap between galaxies is measured on a scale so vast that astronomers typically abandon ordinary units of distance entirely, relying instead on the time it takes light itself to cross it. A total solar eclipse is possible purely by cosmic coincidence, since the sun happens to be roughly 400 times larger than the moon, but also roughly 400 times farther away, making them appear nearly the same size in our sky. Certain regions of space contain such dense concentrations of stars that, if you lived on a planet within one, the night sky would never truly grow fully dark at all. The most distant human-made object, launched decades ago, has now traveled so far that it takes light itself, and therefore its radio signals well over a day to reach Earth. Some scientists believe the universe may contain far more matter than we can directly observe, an invisible presence detected only through its gravitational influence on everything around it. Astronomers detected distant planets orbiting other stars using several clever, indirect methods, including watching for the tiny, regular dip in a star's brightness as a planet quietly passes in front of it from our point of view. A planet is generally considered potentially habitable if it orbits within a particular distance from its star, a zone neither too hot nor too cold for liquid water to exist stably on its surface, sometimes described informally as a just right zone. A distant system discovered several years ago contains no fewer than 7 roughly Earth-sized planets orbiting a single, small, cool star, an unusually compact and crowded little planetary family. Modern space telescopes have grown sophisticated enough to begin analyzing the faint chemical signatures within a distant exoplanet's atmosphere, offering the first real hints of what conditions might actually be like on worlds we'll never visit directly. Beyond ordinary matter, scientists believe a mysterious force, referred to as dark energy, is responsible for the universe's accelerating expansion, though its true underlying nature remains one of the biggest open questions in modern physics. The leftover glow from the universe's early hot beginning, sometimes called the cosmic microwave background, has cooled dramatically over billions of years, but can still be detected faintly in every direction across the sky. Most cosmologists estimate the universe itself is roughly 13.5 billion years old, a number pieced together carefully through multiple independent lines of astronomical evidence. Our own solar system, by comparison, is considerably younger, having formed a little over 4.5 billion years ago from a vast, slowly collapsing cloud of gas and dust. A wide band of rocky debris orbits the sun between Mars and Jupiter, remnants left over from the solar system's early formation that never quite managed to gather into a full planet of their own. Farther out, beyond Neptune's orbit, a vast, icy region contains countless small frozen bodies, including several dwarf planets, drifting slowly through the solar system's cold outer edges. Even farther still, an enormous, mostly theoretical spherical shell of icy debris is believed to surround the entire solar system, the likely distant source of many long-period comets that occasionally swing back toward the sun. One of Jupiter's largest moons is believed to hide a vast liquid water ocean beneath its icy, cracked surface, making it one of the more promising places in our own solar system to search for potential signs of life. Saturn's largest moon, wrapped in its own thick, hazy atmosphere, remains one of the only moons in the solar system dense enough in atmosphere to support the kind of weather and surface liquid cycles found on Earth. The 2 robotic Voyager spacecraft, launched decades ago, each carry a golden record containing sounds, images, and greetings from Earth, intended as a message for any distant intelligence that might eventually encounter them. The International Space Station orbits Earth at an altitude high enough to avoid most atmospheric drag, yet still close enough that astronauts aboard can clearly make out coastlines, cities, and weather systems below. Living in orbit takes a genuine physical toll, and astronauts on long missions experience measurable bone density and muscle loss, requiring dedicated daily exercise routines just to help offset the effects of extended weightlessness. Spacesuits worn during spacewalks function essentially as small, self-contained personal spacecraft, carefully regulating oxygen, pressure, and temperature to protect an astronaut from the harsh, airless environment just outside the hatch. Food prepared for astronauts must be carefully packaged to prevent crumbs and loose particles from drifting freely through a spacecraft's cabin, where they could potentially interfere with sensitive equipment. Mars's thin atmosphere, composed mostly of carbon dioxide, offers little protection from radiation and can't support liquid water on the surface for long, though evidence strongly suggests the planet was considerably wetter billions of years ago. The planet's distinctive reddish color comes from iron minerals in its surface soil that have slowly oxidized over a very long stretch of time, essentially the same chemical process that causes rust. Here on Earth, robotic rovers exploring the Martian surface have traveled many miles across the planet's dusty terrain, sending back detailed images and scientific data that continue to reshape scientists' understanding of the planet's ancient past. The search for life beyond Earth extends well past our own solar system, and radio telescopes continue quietly scanning the sky for any unusual signal that might hint at distant intelligent activity. A well-known equation, developed decades ago, attempts to estimate the number of potentially communicative civilizations that might exist within our galaxy, though nearly every value within it remains, even now, largely a matter of informed guesswork. Life on Earth thriving in extremely harsh environments, from boiling deep-sea vents to frozen polar ice, offers scientists a useful hint that life elsewhere might similarly be capable of surviving conditions once assumed to be far too hostile. Beyond Jupiter's icy moon already mentioned, one of Saturn's smaller moons has been observed venting plumes of water vapor directly into space, suggesting it too may hide a liquid ocean warmed from within. Saturn isn't the only planet with rings. Jupiter, Uranus, and Neptune all have their own much fainter, harder to observe ring systems, composed of considerably smaller and less reflective particles. Large asteroid impacts have shaped Earth's history more than once, and astronomers today actively track nearby asteroids, carefully calculating their orbits decades into the future to rule out any realistic future collision risk. Meteor showers occur predictably each year as Earth passes through trails of dust left behind by particular comets, producing reliable, recurring displays of shooting stars visible from the night sky. A faint glow sometimes visible along the horizon after sunset or before sunrise, caused by sunlight scattering off dust scattered along the plane of our solar system, is subtle enough that it's only clearly visible from especially dark locations. A constant stream of charged particles flows outward from the sun in every direction, known as the solar wind, gently shaping the tails of comets and interacting with the magnetic fields of planets throughout the solar system. The sun's activity rises and falls in a roughly 11-year cycle, marked by the appearance and disappearance of dark, temporary sunspots, cooler regions on its surface tied to intense, shifting magnetic activity. Occasionally, the sun releases enormous bursts of charged particles directly toward Earth. And while our planet's magnetic field offers protection, particularly strong events can still disrupt satellites and electrical systems. Our entire solar system sits inside a vast bubble carved out by the sun's own solar wind, a boundary marking where the sun's influence finally gives way to the wider interstellar environment beyond. Occasionally, an object from beyond our solar system passes briefly through it entirely, and astronomers have now confirmed at least a couple of these rare interstellar visitors, offering a fleeting glimpse of material from another star system entirely. The Hubble Space Telescope, orbiting above Earth's distorting atmosphere, has spent decades capturing extraordinarily clear, detailed images of distant galaxies, nebulae, and stars, reshaping public understanding of the universe along the way. Massive galaxies can bend and distort the light of far more distant objects behind them, a phenomenon astronomers use deliberately as a kind of natural cosmic magnifying glass to study otherwise invisible, faraway galaxies. Scientists believe a mysterious form of matter, detectable only through its gravitational pull rather than any light it gives off, makes up a considerably larger share of the universe's total mass than all the ordinary matter we can actually see. Time itself behaves differently depending on speed and gravity, and astronauts aboard the International Space Station actually age an almost imperceptibly tiny fraction of a second slower than people on the ground. The speed of light remains one of the universe's few true constants, and nothing with mass has ever been observed to reach or exceed it, placing a hard, fundamental limit on how quickly anything can travel between the stars. Wormholes, theoretical shortcuts connecting distant points in space, remain an intriguing mathematical possibility within certain physics equations, though no one has ever actually observed one, and whether they could truly exist remains genuinely uncertain. Engineers have long theorized about a structure connecting Earth's surface directly to orbit, though the material strength required to build one remains well beyond anything currently available. Some scientists have speculated about enormous, self-sustaining spacecraft capable of carrying multiple generations of travelers across the vast distances between stars, since even at incredible speeds, interstellar journeys would likely take centuries. Modern rockets face an ongoing challenge from the sheer amount of debris now orbiting Earth, and space agencies carefully track thousands of fragments to help spacecraft and satellites avoid dangerous collisions. Thousands of satellites now orbit Earth, providing communication, navigation, and weather monitoring, quietly forming an invisible layer of technology surrounding the entire planet. The GPS technology so many people rely on daily depends on remarkably precise timing, and satellite clocks must actually be adjusted to account for the subtle effects of relativity, or location calculations would drift noticeably inaccurate within a single day. Space weather, driven largely by solar activity, can measurably affect technology here on Earth, occasionally disrupting radio communication and, in extreme cases, electrical power grids. Billions of years from now, our own sun will eventually swell into a much larger, cooler star, likely engulfing the innermost planets before eventually settling into a small, dense, slowly cooling remnant. Some cosmologists theorize about the universe's ultimate long-term fate, including a slow, gradual scenario where stars eventually burn out entirely and the universe fades into a cold, dark, mostly empty state over an almost unimaginable span of time. A small number of physicists have proposed that our universe might be just one among countless others, a genuinely speculative idea that remains, for now, far beyond what current instruments can actually test or confirm. Newly discovered exoplanets are typically named using a systematic combination of letters and numbers tied to their parent star, a practical naming convention quite different from the more evocative names given to planets within our own solar system. The very first planet confirmed to orbit a star other than our own sun was discovered only in the final years of the 20th century. and thousands more have been confirmed in the years since. Many stars in the galaxy aren't solitary at all, but exist in pairs or small groups, orbiting a shared center of mass in a slow, gravitational partnership that can last for billions of years. Star clusters come in different forms, and while some are loose, relatively young groupings of stars born together. Others are extremely old, tightly packed spherical clusters containing hundreds of thousands of stars bound closely together by gravity. When our galaxy eventually merges with its nearest large neighbor, billions of years from now, the two spiral shapes will gradually distort and combine into a single, larger galaxy, its structure reshaped entirely by the slow gravitational dance. Galaxies themselves come in several broad shapes, including graceful spirals like our own, smooth, rounded elliptical galaxies, and irregular galaxies with no clear defined structure at all. Our own galaxy belongs to a small, relatively modest cluster of galaxies known as the local group, itself just one small neighborhood within a far larger, sprawling supercluster of galaxies. On the largest scales astronomers can observe, galaxies and galaxy clusters aren't scattered randomly throughout the universe, but instead form a vast, thread-like structure, sometimes described as a cosmic web, with enormous empty voids stretched between the strands. Certain stars burn through their fuel so quickly and violently that they live only a few million years before exploding, a dramatically short lifespan compared to smaller, more modest stars capable of shining steadily for tens of billions of years. The color of a star offers a genuine clue to its surface temperature, with cooler stars glowing a deep reddish orange, and the hottest stars burning a brilliant, intense blue-white. Certain distant galaxies harbor extraordinarily bright, active cores, believed to be powered by enormous black holes, actively pulling in surrounding gas and dust, releasing tremendous amounts of energy in the process. Nearly every large galaxy studied so far, including our own, appears to host a supermassive black hole at its very center, quietly anchoring the galaxy's rotation from a region far too small to observe directly. The night sky looks different depending on where on Earth you happen to be standing, and certain constellations visible from the southern hemisphere remain permanently hidden from observers living farther north. And the reverse holds true as well. Ancient astronomers across many separate cultures independently grouped stars into recognizable patterns and figures, weaving their own distinct stories and mythology into the same night sky shared by everyone on Earth. Certain stars appear to twinkle noticeably, while planets generally shine with a steadier light, a subtle difference caused by the tiny apparent size of a star's light being more easily disturbed by moving pockets of air in our atmosphere. The moon always shows the same face toward Earth, a result of its rotation being perfectly matched to the time it takes to orbit our planet. A gradual gravitational effect built up over a very long stretch of time. Eclipses of the moon occur when Earth passes directly between the sun and moon, temporarily casting our planet's own shadow across the lunar surface, often tinting it a deep reddish color as sunlight bends through Earth's atmosphere. Certain rare alignments allow more than one planet to appear close together in the night sky at once, a striking, temporary, visual grouping that has no real effect on the planets themselves, despite looking dramatic from Earth. The largest volcano-like structures found on some moons in the outer solar system don't erupt molten rock the way volcanoes on Earth do, but instead vent extremely cold material like water, ammonia, or nitrogen in a process scientists call cryovolcanism. Certain asteroids are massive enough to have their own small gravitational pull, occasionally capturing tiny natural satellites of their own, effectively becoming miniature systems in their own right. Space probes sent to study the outer planets often rely on carefully timed gravitational slingshot maneuvers, using a planet's own gravity to gain speed and adjust course without needing to burn additional fuel. The coldest temperatures ever recorded anywhere, warmer only than theoretical absolute zero, have actually been achieved briefly in laboratories on Earth, colder even than the depths of space itself in certain controlled conditions. Distant quasars, among the most luminous objects known in the entire universe, can outshine the combined light of every star in an entire ordinary galaxy, despite being powered by a region not much larger than our own solar system. Certain binary star systems consist of two stars so close together that material can actually flow from one star directly onto its companion, sometimes triggering dramatic explosive events on the receiving star's surface. The universe's expansion doesn't work quite like an explosion pushing matter outward into empty space. Instead, space itself is stretching, carrying galaxies apart from one another as the fabric between them continues to grow. Certain especially massive stars end their lives in supernova explosions so bright that, briefly, they can outshine their entire host galaxy, visible even in daylight from Earth, if one occurs close enough within our own galaxy. The elements that make up nearly everything around you, including your own body, were forged either in the hearts of ancient stars or in the explosive deaths that ended their lives, scattered outward to eventually become part of new stars, planets, and people. And somewhere out there, beneath all of it, the same slow, patient rhythm continues exactly as it always has. Stars quietly burning, galaxies slowly drifting, needing nothing from anyone awake to keep turning through the dark. And so, tonight, we finally arrive exactly where these 100 nights of facts always seem to lead, back out beneath the same wide, quiet sky, however far we've traveled to get there. The same stars that have watched over every single thing we've talked about across every one of these nights are, right now, simply burning quietly overhead, exactly as they always have. Somewhere a new star is just beginning to glow, and none of it needs anything from you right now except your rest. You've drifted tonight through galaxies and black holes, past stars older than memory and planets stranger than imagination, all the way out to the very edge of what we understand. The whole vast, patient universe turning quietly above you, exactly as it always has. Let it hold you now, the way it's always held everything else. Let your breathing settle into its own slow rhythm. There's nowhere else you need to be. Nothing else you need to understand tonight. Just this quiet sky and this quiet rest, drifting gently together in the dark. Sleep well, and I'll see you next time for another 100 facts, drifting softly into sleep.